of routing protocols. Generally, it's EIGRP that we run. I also want to take a look at how it's run with OSPF, some of the intricacies that you have with OSPF running on Dmvpn. We'll take a look at that. We'll take a look at all the three phases, phase 1, phase 2, phase 3. But before we get started, let's understand what Dmvpn brings to the table. Why do I want to do Dmvpn versus a normal point-to-point GRE with IPsec on top of it to set a connection between two sites? Well, when you do when we do a normal site-to-site VPN, let me just draw out, get my pen up. So let's say I have a couple of sites that I want to set up over the internet, make a VPN to connect the two sites to each other. And I have two sites, very simple configuration. I'll set up a GRE point-to-point setup. Although it's not encrypted, it does allow me to tunnel my networks, my private networks from, let's say, 10.1.1.0 to, let's say, 10.2.2.0 through the tunnel. The way you do that is you set up a small config on your tunnel interface, give the tunnel an IP address. That becomes the virtual network that is connecting router 1, router 2 to each other. Just do /24, although on the iOS you would need to run the 255.255 type of setup. Here I would put the public address of router 1, let's say 192.1.10.1, and the public address of router 2 is 20.2, and I would say tunnel source destination. The source would be 192.1.10.1. This would be a point-to-point setup. So at this point, I basically ran a cable logically, virtually between router 1 and router 2 to connect them up to each other. They're both connected on the same network, which is 192.168.1.0. Because they're now virtually connected to each other, I can run a routing protocol to route 10.1.1.0 over 10.2.2.0 to each other. The problem with this type of setup is that it is a point-to-point type of setup, in the sense that if I wanted to connect multiple sites and I want to scale this, I would not be able to do that. I can, but it would be a big task to set up, let's say, 20 sites to each other, connecting over the internet. So that's where MGRE comes in. MGRE allows us the ability to connect these multiple sites to each other that are connected on the internet, rather than over a separate point-to-point tunnel between each other. I can create a single network, single tunnel interface, having multiple points on it. So logically, we're all connected to a multi-point network. You guys can hear me okay, right, Catherine? Because it's giving me a message saying that people might have problems hearing you.
No, we can hear you just fine.
Yeah, loud and clear.
All right, good. It's popping up a message on my screen saying that come closer.
Oh, just ignore that.
Right.
Just ignore that. You're good.
All right, good. So in a multi-point type of setup, you would basically have one network, 192.168.1.0, same, I'm using the same network over here, .1, let's say .2, .3, .4, and .5. So I would have 5 different sites connect to each other over the same network. If you guys are old enough to know there was a technology by the name of frame relay that existed, maybe still does, it's the same type of setup where you'd have a single multi-point network where you would need to do a mapping to figure out, if I want to get to a particular destination, what is the public address of it. In frame relay, we would do the mapping to map over a delc to an IP address. Over here, we're doing a public to private IP mapping. This is called MGRE. Let me just do it real quick so you guys understand how it works. It's static MGRE that I'm going to do over here. So in my network over here, let's get rid of this drawing of mine. In my network over here, what I have is I've already set this up. Basic configuration, router 6 is my internet. I have 5 sites connected to it. 192.1.10, 20, 30, 40, and 50 are the public addresses of these different sites. Each network, each router behind it has a couple of loopbacks I'm using as my internal networks, and I want to be able to connect up to each other over the internet using private networking. So one of the ways to do it, to connect these 5 sites into a single network, was static MGRE. Let's take a look at how to do that. So if I go onto my router 1, actually let me do it in Notepad because I can easily copy paste it after that. So in Notepad on router 1, what I would do is I would set up a tunnel interface, like a normal point-to-point tunnel interface with subtle differences. So this would be my tunnel IP. Now I would need to specify what my source is. There's 2 different ways of specifying the source. You could either specify the source manually, my public address. So any packet that leaves this particular tunnel interface will use this as a source address on the outer header, the public header. At the same time, generally when I do a point-to-point type of setup, I would specify a tunnel destination. Let's say this guy over here. But in a point-to-point setup, I can only do a single destination. On a tunnel interface, which by default sets up GRE point-to-point, I can only do one destination. In this case, I have multiple destinations. So if I want to go to 192.168.1.2, what is the destination for that? If I want to go to 192.168.1.3, what's the destination for that? So the first thing that I need to do is change my mode over here. I cannot specify a single destination. I need multiple destinations. So the first thing that I'll change is the mode. The default mode, if you don't change it, on the tunnel interface is GRE point-to-point. So the first thing that I'll do is change my mode to tunnel mode GRE multipoint. The next thing that I need to do is I need to get a protocol that will figure out if I want to get to a particular destination. For example, if I want to reach 192.168.1.2 on the tunnel, what is the corresponding destination public address? So I need to write that down manually over here. This is done not by MGRE, but a supporting protocol called Next Hop Resolution Protocol, or NHRP. So the first thing that I need to do over here is I need to enable NHRP under the tunnel interface. That is done by using the network ID command. Network ID command is just to enable NHRP on the interface. The ID that you specify over here is locally significant. So it can be any ID. A lot of people ask me, do I need to match this ID between the different interfaces? No, you don't. It's a local, think about it being like your router OSPF process ID command, which is locally significant. Unless you go into MPLS VPNs where it does have a significance between the different devices, but normal routing, it is locally significant. Same thing with the NHRP network ID. It's just to enable NHRP on that tunnel interface. So once I do that, then I'll just use normal NHRP mapping commands to specify if I want to reach 192.168.1.2, the public address is 20.2. If I want to reach 1.3, the public address is 30.3. These are the public addresses for the corresponding devices over here. Now, this is not scalable, but this is MGRE. I want you guys to understand that so that we can move into Dmvpn. So this would be how I would set up a simple MGRE tunnel to connect the different sites to each other. So now if a packet comes into my routing table, says I want to reach 192.168, let's say 1.4, I'm sitting on router 1. It checks the routing table, it sees that 192.168.1.0 is directly connected via the tunnel. And you guys can see that in your routing table. It says, oh, it's through the tunnel. Let me check the tunnel. When you go to the tunnel, it says my mapping is done by NHRP. It checks the NHRP mapping table, in which I've statically mapped that 192.168.1.4 is mapped to 40.4, which is this guy over here. All right. So in essence, when the packet comes in, let's say I want to ping from router 1, I'm pinging router 4. So 1.1, I'm pinging this guy over here. When the packet comes in, what I'm going to do over here is I'm going to put my source, whatever my tunnel source is, in the outer header over here. and I am going to do a mapping for 192.168.1.4 and look at the mapping over here to see what do I put in the outer header corresponding to the inner destination. So in the inner destination, I see 192.168.1.4, and that's what the mapping is used for, to figure out what to put on the outside header. Packet is created and sent across. All right, this is MGRE. So let's do that. Let's see if it works over here, and then we'll take a look at the disadvantages of doing something like that. So copy it. I'll go to router 1 and paste it. While it's coming up, I will go ahead and do the same thing for router 2, almost the same thing. All I do is change my IP address. And the other thing that I would also do, just to make it a little bit more scalable, I'll just change the source. Rather than putting the IP address manually, I'll say get the IP address from the E00 interface. So whatever the IP address of the E00 interface is, that's what I want you to use. I'll change the mapping. I don't need a mapping for myself. I do need a mapping for 10.1. The rest, 3, 4, and 5 are the same. So I'll copy this, and I'll go to router 2 and paste it. Now, if you want to check, you can check your mapping table over here. Show IP NHRP. It tells you that if you want to reach 192.168.1.1, the outside address, the public address is 192.1.10.1. So if I go in and try to ping 192.168.1.1, which the router in the middle, this is the internet router, all it has is just the public addresses. If you check the routing table, all it has is public addresses. It doesn't have any 192.168. But if I go over here and try to ping it, what's going to happen over here is we'll go through the whole process. It's going to say, I want to ping 192.168.1.1. Actually, I am 2. I'm sitting on 2. And I want to ping 192.168.1.1. Let's figure out the outer header. The outer header, based on my tunnel source, is the IP address of E00, which is this guy. Now, the destination, when I check my routing table, let's do that first. When I check my local routing table over here, it says 192.168.1.0, which is the public address, is reachable via the tunnel interface. If I check my tunnel interface over here, it says it is a MGRE tunnel. All right. So if it's an MGRE tunnel, it needs to do the resolution, checks the NHRP table. In the NHRP table, it says, oh, if I want to reach 192.168.1.1, I need to put this as the public address. Puts it over here based on that, and it makes a connection. So let's try to do that and see if it's successful. Boom. So I can go from router 2 to router 1. The packet's going like this. You guys can see my drawing at the bottom of the screen. That has the red, which is the outside header, the blue, the inside header. That's the way the packet goes. Although it's a clear text packet, the middle router, which is router 6, just looks at this for forwarding, the outer header. Everybody okay with this? Yes? Now, let's go ahead and finish the whole config up. If you take a look at it, what do I do on R3? Let me finish it. We'll talk about that. The question Nino asked was the coloring of the Secured Crt. So on R3, I'm going to do the same thing. Yes, there absolutely is, because I would say it adds a header of about 40 to 50 bytes. So you might want to change your MTU to make it a little bit more efficient. So over here, 1.3, I need a mapping for 1. I do need a mapping for 2, but I don't need a mapping for myself. So on 3, I'll change that, copy it, and paste it over here. So my router 3 should also now be able to communicate to the other guys. So 1 is reachable, 2 is reachable again through the mapping. Let's finish the other one. 1.4. So the only thing that I'm changing over here is the IP of the tunnel, and then I change the mappings. I change the mapping for my own to the one that was from the previous one, and I should be almost done. I need one more, so I can ping 192.1.1, 2, and 3. By the way, this is MGRE. This is not Dmvpn because it's all manual. So 1, 2, 3, 4. No, I don't need 1, 2, 3 actually. I'm 5 now, right? So I need 4 and I need 3. It's out of order, but that's okay. So now I have the ability to ping all the different devices on the same network over here. So they're all reachable. All right. What's the problem with this? The whole purpose of doing this multi-point GRE tunnel was scalability. Yes, I don't have multiple tunnels now, but in the same tunnel, if you take a look at the configuration, I need to have a mapping for each device. Not only that, the other problem with this type of setup is that I do need all the sites to have a static public address because I need to map it over. So the destination address that you see, 10.1, 20.2, and all that, it cannot change. So everybody over here, all the sites that you have that are connecting to this multi-point tunnel need to have static public IP addresses. So that's the other drawback that you guys have. So if you have certain sites, small sites that do not have the ability to have static IPs, that's going to be an issue. That's where Dmvpn comes in. How does Dmvpn work? With Dmvpn, what I'm going to do is, actually I can just use this for my whiteboard. In Dmvpn, what happens is, it's the same type of setup, but the thing is, the mappings are done dynamically. In a Dmvpn type of setup, it's still a MGRE tunnel. It's a multi-point tunnel. But what I do is I designate one of the routers as what is known as the next hop server, NHS. It's like a dynamic DNS server, DDNS. Like, it's not the same, but it's like it. It's a resolution server. What it does is it basically allows the other devices, let's say router 2, router 3, router 4, and router 5, to come up and register their mappings to this dynamically. So what I'm going to do on 2, 3, 4, and 5, I'm going to tell them, hey, listen, your next hop server is 192.168.1.1. And in order to reach it, you need to go to 192.1.10.1. So whatever your address is on the outside interface, your public address, I want you to go and register yourself to router 1 and tell router 1 what is your public address. So as soon as I configure R2 with the NHS and map it, it is going to go up to router 1 and tell him, hey, listen, you know what? My IP address is on the tunnel 192.168.1.2, and the way you reach it is this guy. Please register me. This guy's going to do the same thing. Four is going to do the same thing, and 5 is going to do the same thing. You guys get the gist, right? I'll just put it in anyways. So now the NHS has all the mappings created dynamically, just like dynamic DNS. It gets an IP address from the DHCP server. It goes and registers with the DDNS server. The DDNS server now has all the dynamic mappings. So this allows us two capabilities. Number one, on each of the spoke routers or these devices over here, the clients. I don't need to do all the mappings for everybody. I just do a mapping for the next hop server, the central server. Yes, at this point, you have a single point of failure. You do have the ability to have multiple next hop servers to get around that problem. But my focus right now is, rather than the redundancy part of it, is the working part of it. But yes, you do have the ability to have multiple next hop servers, the NHS servers. So if just in case it goes down, you still have the mappings. Now, over here, I have one mapping. Even if the other spokes for dynamic, they would have mapped their dynamically assigned ISP address, the public address, to the next hop server. So he knows all the addresses now. So now let's say router 2 wants to talk to router 3. In his mapping table, he just has one entry. What he does, it says, hey, listen, NHS, I have a packet that I need to send to 192.168.1.4. Do you happen to have the IP address for 192.168.1.4? Sends a request over here, gets a resolution, creates the NHRP mapping dynamically, and keeps it by default for 2 hours. So for the next 2 hours, I don't need to go to the next hop server to be able to reach either one of the three devices. So now I've scaled down. The scalability issue that I had is gone, because now I only want to point to the next hop server, and the next hop server will resolve all the addresses for me. You get my point. This is done dynamically, hence the dynamic multi-point VPN type of setup. All right, rather than doing it statically. How do I do this? Let's take a look at the config on the next hop server itself, and then the clients. What do I do on the client side? All right, much more dynamic in the sense that, number one, I don't need to do a lot of manual work on the other devices. Plus, if in case I have sites that have dynamic IP addresses assigned to them by their ISP, I don't have an issue with that. Okay, so I am going to take a look at the old config. This was for MGRE. Now let's do a Dmvpn config over here. I'm going to go to the one that I'm going to make into the NHS server. In here, I'm going to get rid of the older tunnel. So everything that I configured on the tunnel is gone. And then I'm going to configure a new tunnel interface over here. IP address 192.168.1.1. Tunnel source, I'm going to make it like that. Tunnel mode, GRE multi-point. Once I'm done with that, I need to enable NHRP over here. Specify that. And that's pretty much all I need to do on the next hop server. Everything else will be done dynamically. Now, I'm not running routing right now. I'll show you how to do routing as well. But for right now, just to connect the 4 sites or 5 sites to each other in a dynamic manner. So how do I do that? So on the next hop server, this is all I need to do, because everybody else will register to me dynamically. Let's do this on router 1. Notice the first command over here is I'm getting rid of the old tunnel. So I won't have any of these configs anymore. So copy it, go to router 1. So the old tunnel is gone. If I look at my mapping right now, I don't have any mapping, it's blank. But on the other side, on the client side, router 2 through router 5, no interface, tunnel 1, interface tunnel 1, IP address, let's start with 2, tunnel source E0/0, tunnel mode GRE multi-point, IP NHRP network ID, and then the commands for NHS. My NHS server is the tunnel IP of the NHS, not the public IP, the tunnel IP, because NHRP is run through the tunnel. How do I reach it? In order to reach 192.168.1.1, this is the public IP of it. So when I do need to do my registration, because I've been configured with NHS, it tells my tunnel interface, as soon as you come up, you get an IP address assigned to it, please go and register that with the next hop server. And this is what the command does. And in order to reach it, this is where I go and reach it. So copy it, Again, if you look at the top, it says no interface tunnel 1. So it's getting rid of the old tunnel config and putting the new thing in. Now, as soon as I do that, my tunnel comes up. I do have one mapping that is done. And if you take a look at it, that tunnel mapping is for the next hop server. It is done manually. If you guys remember, router 1 had no mapping because I did not do any static mapping over here. Now it should have one registration, which was done dynamically, where 192.168.1.2 registered itself as 20.2. So now if I do want to go to this guy, I will be able to go there. Let's do the same thing on R3. So I'll just do it individually, so you guys can have these notes later on. Oops. Again, don't forget to get rid of the old tunnel because the other tunnel has a whole bunch of other config. The rest remains the same because everything is pointing towards the next hop server, the NHS. So router 3. Done the config on router 3, which is pointed to the next hop server. If I go over here and I do it show IP NHRP, you will see that I have mappings, manual mappings created now. So now router 3, again, right now only has one mapping towards the next hop server. It does not have a mapping for 2 yet. It will create it dynamically on a need basis. But before I do that, let me finish up on all the other configs. Just change the IP. The rest of the config is exactly the same on all the other clients, spokes, whatever you want to call them. One mapping over here, which is for the NHS. Here, as new devices come up, they do the mappings over here. Now, this is extremely scalable. You just need to have a beefy router at the hub site, the next hop server, because it is going to have all the mappings depending on how many sites you want to connect up. One of the networks I set up, I had about 200 sites worldwide. It was a MNC, multinational company, and it had about 200 sites that were connecting over here. I have all my mappings done. All right. Now, let's go to router 5, and I want to, let's say I want to communicate to router 2. If I take a look at my mapping, I only have one mapping. Let's say I want to go to 192.168.1.2. I don't have a mapping for it. Rather than doing a ping, I'll do a trace route over here because I want you guys to see what happens over here. When I do a trace over here, it says, hey, I want to go to 192.168.1.2. If you check the routing table over here, again, 192.168.1.0 is connected via what? The tunnel interface. Goes through the same process. Checks the NHRP mappings. It doesn't have any mapping, but it knows there's a next hop server configured. So how do I go to the next hop server? I tell it, listen, you know what? I want to get to 192.168.1.2. Do you happen to know the public IP of it? It says, yes, I do. Sends down the registration. Sorry, the resolution. Tells it, hey, listen, if you want to get to 192.168.1.2, the public IP is 20.2. Go there directly. Don't come to me. Go there directly. But the first packet will go to where? Towards the next hop server. It's like a default gateway of sorts for NHRP. So I'll do a trace route to 192.168.1.2. I don't have a mapping yet over here. So as soon as I do that, you'll notice the first trace goes to 1. But it's a single hop because it's automatically going to send him a resolution and it goes direct to 192.168.1.2. It's not 2 hops. It doesn't show you a 2 hop in the trace route. It just shows you a single hop. If you take a look at your NHRP table right now, I have a new mapping created for 192.168.1.2, which was created dynamically. Does that make sense, guys? Everybody okay with this? And it stays there for about roughly 2 hours. Now, if I do another trace route, I am not going to go to the next hop server. I'm going to go direct because I have a mapping for 192.168.1.2. Take a look. It's direct. Everybody okay with this? You guys understand that? Yeah, I only see the ones for everyone. Now, at this point, I have not done any routing. I've just connected the different devices to each other. I'm not actually, the whole purpose of doing this was to actually be able to do routing so that my internal networks over here can connect to each other. All right? But at this point, at least, what I have accomplished over here is that all the devices right now are logically connected to this tunnel network, 192.168.1.0. They are able to communicate to each other directly. They're not going through the next hop server. They're using the next hop server more like a resolution device, like a DNS server. How do I go to google.com? Once they find out how to go to google.com, they don't go back to the DNS server. They go directly to the end device. So it's more like a control plane type of mechanism that's happening between the hub and the clients and the next hop server. But I'm not done. The main thing, as I said, my objective over here was to be able to communicate and have the routes from the internal networks propagate to each other. So I need to run a routing protocol. But there's an issue with that. The issue with the routing protocol over here is when any type of routing protocol, generally the IGPs, when they communicate, what's the packet look like? Whether it's RIP, EIGRP, OSPF, any of them. Their packet is going to look like this. Multicast. So when I send the hello packet out to establish my neighbor relationship in EIGRP or OSPF, RIP doesn't have a hello packet, but the entire update is multicast. It's going to say 192.168.1.x, whatever your device is. Now over here, on the outside, let's say I'm sitting on 2, just as an example. I'm sitting on 2 and I want to send an update. Who do I send the update to? 192.1.20.2 is my source. What's my destination? Where's the mapping for this? Did I do a mapping for it? The next hop server is not going to resolve multicast mappings. It only resolves unicast mappings. So when I see a multicast address over here, I need to tell my router what address do I need to put over here. I'll get to that. In a hub and spoke environment, does all the traffic go through the hub? We'll get to that. I'll talk about that's the phase 1, phase 2, phase 3 part of it. Good question. Just hold on to it. That will be answered as we go through. So source is this. What's the destination for my multicast update? I don't have a mapping for the multicast. So what I need to do, I need to designate my next hop server as my routing hub. Rather than establishing a neighbor relationship with everybody, I am going to establish my routing neighbor relationship or adjacency only with the hub. Again, from a redundancy perspective, you might want to have 2 of them at least. But from the perspective of scalability, you don't want to do it with everybody because otherwise I would need to maintain neighbor relationships with everybody. So what I'm going to do on all the different spokes is I'm going to do a map, a special map that says if a multicast packet comes in, send the multicast update to the hub. So when it sees this type of packet for a routing protocol like EIGRP or OSPF or for that matter RIP, it is going to send the update to the next hop server, which now also becomes my routing hub. So everybody will establish a neighbor relationship with the hub. But the problem is on the hub, what type of mapping do I do? Over here, everybody points to the hub. On the hub, what I tell it is, hey, listen, if you have a multicast packet come in that needs to go out, send it to each one as a unicast that has registered to me dynamically. Send it to all my clients. So it checks the NHRP mapping table for anything that has registered dynamically. It's going to take that packet and send that multicast packet, creates multiple packets, and sends a multicast update to each one of those clients. So on the hub, the next top server, I don't do a map multicast to a specific address. I do it to this entry in my NHRP table that has been registered as dynamic. So let me just show you that real quick over here. If I go to router 1, all my mappings over here are based on what? Dynamic. So what I'm going to do over here on the next top server, on the hub side, the routing side, is what I'm going to do is I'm going to specify, oops, this is the wrong one, this guy over here, IP NHRP map multicast dynamic. You get my point? So it will send its hello packet to everybody that has registered to me dynamically, so to all the clients. On the device side, the client side, I'm going to do the mapping only towards what? Map multicast towards 10.1. So if a multicast packet needs to be resolved, I'm going to resolve it to only to that particular guy. Let's redo the hub with a map multicast dynamic on the client. Force a registration by getting rid of the tunnel for back in. Otherwise, sometimes you need to bounce the interface. If I was doing it from scratch rather than explaining it, I would have done it up front. So I would do the same thing over here on the other devices. So this is what a simple Dmvpn network setup looks like. Right now, I should be able to run a routing protocol as well. And the last one over here. So I have a map multicast dynamic. So if I run a routing protocol, I know where to send the updates to. Let's go ahead and run the routing protocol then. So the first routing protocol I want to take a look at over here is EIGRP. So the next set of the lecture is for running EIGRP on this tunnel interface. I made my tunnel ready for running a multicast-based routing protocol. Everybody okay with it so far? You understand what I have done in terms of the config, every single command, and the significance of every command in there. Do you guys understand that? Why are you putting it in? All right, brilliant. So let's move forward and run a routing protocol. So running EIGRP as the routing protocol on the Dmvpn tunnel. On every router that I have created over here, I have some two loopbacks that I have created over here. So from router 1's perspective, I have 10.1.1, 10.11, router 2. I'll show you that. It's a very simple config because it's just got interfaces on it on R6. So 10.2 over here, 10.3.33 over there, 10.4.45, 44, and 5 and 55 on this guy. Router 4 is a very simple config. If you take a look at the topology over here, router 6 over here is just directly connected interfaces on router 6. 10, 20, 30, 40, 50. That's all I've done. I just connected them up. In real life, this would be the internet, so it would just, yeah, it's just connecting these devices on the public network and tunneling everything. It's going to just see the outside address. So if you look at the config of router 6, nothing in there, just interfaces with IPs. The routing table looks like this. Good, very simple setup. Now, you guys have seen the networks. What I'm going to do over here is run the routing protocol on router 1 through router 6. It's the same type of setup. What I'm going to do is I'm going to run EIGRP in the classic mode. It's a habit, although in the newer iOSs you don't need to do it. No auto summary is done by default. Classic meaning versus the name mode. So I'm enabling it on the tunnel interface as well as on the internal loopbacks that I have. And this is the same type of EIGRP setup I would need to do on router 1 through router 5. I don't need to run EIGRP because I'm running it through the tunnel on router 1, 2, 3, 4, and 5. Same type of setup because everybody is enabling it on the 192.168.1.0 network and the 10 network. What about stub? EIGRP stub? Well, that depends on the rest of your network that you have. Split horizon, oh, I'll get to that. We need to do that, but I want you guys to do it one step at a time. I want you guys to see the issue and resolve it as we go along. So let's do that on router 1. Run EIGRP. Router 2, run EIGRP. 3, run EIGRP. Because they're all on the 10 network, I have the ability to do that. And as soon as I do that, everybody should establish a neighbor relationship with whom? With the routing hub, which is my next hop server. And if I check my routing table over here, what do you guys see over here? All the different networks, 10.2, 10.3, 10.4, all of them are there. Everybody okay with this? So my routing is running, but the problem is, as Vinod rightly pointed out, I'm running EIGRP as my routing protocol, which is a distance vector routing protocol. By default, EIGRP has split horizon turned on. And all the routes over here are being learnt on router 1 via the tunnel interface. So he gets 10.2 to 10.5, all right? But he's not going to send these routes that he learned from where? The tunnel interface back on the tunnel interface by default. Because of split horizon. Let's take a look at that and we need to fix it. So it's something that you need to be aware of in EIGRP. So I have all the routes on the hub, as you guys saw. But if I go to router 2 and do show IP route EIGRP, I will only see the hub routes. I don't even see the other routes. All right. So the first thing that I need to do to make EIGRP run over your MGRE tunnel interface running Dmvpn is going to be to disable split horizon. Where do I need to disable split horizon over here? Where's the only place I need to do it at? Only on the hub, because the tunnel interface on the hub, right, David? I don't need to worry about the spokes because they're not receiving and sending back. Everybody's sending it to the hub, the routing hub. So let's put that in your notes as well. Disable split horizon on the routing hub. How do I do it? Go under the tunnel interface. No IP split horizon EIGRP 100. That's how you disable it for EIGRP. I'll just do it manually over here. Interface tunnel 1, no IP split horizon EIGRP 100. It will reset the neighbor relationships. There you go. Because I have changed the setup. As soon as I do that, it doesn't change anything on the hub. I still get all my routes. I was getting them in the first place. But if I go to my client now because of the split horizon being disabled, I am getting the routes from the other guys. Everybody okay with that? So now I have a working network with EIGRP. And this is what I needed to do to get EIGRP up and running with Dmvpn. If you guys are cool with this, I'll move on and talk about the different phases. That's where the data traffic flow. Remember, somebody asked me about the traffic. Absolutely not. I don't have a neighbor. If you take a look at it, the only neighbor that I have, Charlie, is my hub. I don't have a neighbor with the other guy. I'm getting all my routes from where? From the hub. So if you take a look at your EIGRP, it's coming through there. But you want to go directly to a particular neighbor. Is that what you're looking for? I don't want to go through the hub and all. Is that what you're getting towards? Hang in there. Let's take a look at, you'll see the traffic flow because the metrics are generally for traffic flow. Now, this is pure routing on a Dmvpn type of setup. What is the routing flow over here for all the routes? If you take a look at the routing flow is in a hub and spoke environment or hub and spoke type of setup. This is the routing hub. Everybody sends the updates to him. And he is the one that is responsible for sending the routing updates to everybody. This is your control plane aspect of it. So the control plane, the routing neighbor relationships are all done between in a hub and spoke environment. Yes, for redundancy's sake, you might want to set up two next hop servers and routing hubs. But that's a discussion for a different day. My focus is right now on getting it up and running with one and showing you how you have different ways of allowing the traffic to flow. So we've all agreed that the routing traffic, the control plane traffic is in a hub and spoke manner because I only have one neighbor relationship set up that is set up with the hub. How about the traffic? If you analyze your routes right now on router 2, for example, I want you guys to take a look at the next hop. All the next hops over here are pointing towards what? 1, the hub. So if I want to do a ping or a trace route or send a packet from router 5 to router 4, router 5 to 3, 3 to 2, whatever spoke wants to talk to whatever spoke. I'm not talking about on the MGRE tunnel, but for the networks behind me, and which is majority of your traffic. Let's say 10.5 wants to talk to 10.2. If you look at the next hop over here is 192.168.1.1. Every time router 5 is going to try to resolve 192.168.1.1, even if it wants to go to 2, 3, 4, or 5. So in this case, your traffic flow is a hub and spoke environment. So all the traffic will go through the hub in this type of setup. And this is known as Dmvpn Phase 1, where all the data, all the traffic flows in a hub and spoke environment. The flow is hub and spoke. Why? Because the next hop of your routing update is the hub. Let's take a look at it. If I do a trace route, do you guys remember the first physically, absolutely, physically traverses through it. So if I do a trace route for, let's say, 10.2.2.2, from, let's say, 10.5.5.5, how many hops do you see over here? 2 hops. Let me do it again, just to make sure I'm not resolving anything or it's not improving. It's still 2 hops. If I go to 3, it's still 2 hops. Everybody okay with this? Why is that? The reason is my next hop in my routing table is 1. So when the resolution comes in, I'm not resolving 192.168.1.2 or 3 or 4. I'm resolving 1 because I want to resolve my next hop. So let me write that down for you guys. This is the behavior of Dmvpn with EIGRP in this phase. All traffic traverses through the hub. This is the default setup when you run EIGRP as the routing protocol on Dmvpn. So if you run Dmvpn by itself and you run it like that, it is going to be hub and spoke. You might say it's not good. Yeah, you're right. In terms of efficiency, it's not good because all the traffic now is going through the routing hub, which becomes your bottleneck. Not only that, it leads to inefficient routing. All right, just to give you an example, let's put some geographical locations over here. Let's say this is LA. Let's say this is Boston. And this is New York. Router 3 wants to communicate to Router 4, Boston to New York. It first needs to take that cross-country flight to LA and then come back into Boston, which, although on the internet everybody would be able to talk to each other directly, but in this case the traffic is traversing through LA before it gets to New York. Not good for VoIP. It's not efficient, but at the same time, from a security perspective, you might want to have some centralized policies. Which control which spoke talks to which spoke. And that is something that is what this is good for. So if you want to control which spoke talks to which spoke, and you have some policies defined on router 1, this will force the traffic to come in through where? Through router 1. Do you get my point? So by default, it is phase 1. I'm not saying it's good, but it depends on the situation that you're in. So if you want this from a perspective of security policies, yes, Fred, exactly right. If you want to control what traffic goes where, this is the phase for it. That's phase 1. So what is phase 1? What do you get out of phase 1? You get centralized traffic. All the traffic goes through the central hub. It basically follows your routing traffic. And why is that? Because the default behavior for EIGRP is this. Normally, if you have router A sends traffic to B. What's the next hop for B? It should be A, correct? B sends it to C. What's the next hop for C? It should be B. Everybody agree? And that's exactly what's happening with the EIGRP by default. So when router 3 sends the update to router 1 gets it. He sends it back because I disabled split horizon to 4. He changes the next hop to 1. So everybody is getting the update from 1.1. That's the default behavior of EIGRP. Although it's going on the same interface, it is following through this. You guys get my point? So because of that, when you go to your routing table, you will see all the updates are coming in from where? From this guy. What if you don't want to do that? What if you do want the traffic to go directly from spoke to spoke? I don't want to have this inefficient data forwarding, traffic forwarding. The way you do that is you go back onto your hub and you tell your hub, listen, don't change the next hop. I want the next hop to remain unchanged. Remember how in BGP, if you guys have worked with BGP, there's a thing called next hop self, where you change the next hop to self? Over here, you're doing the opposite of that. You're saying don't change it. Where? On router 1. So if router 1 doesn't change it, what's going to happen over here is when 2 sends an update to router 1, the next hop over here right now for all the routes from 2 are 192.168.1.2. And I'll tell router 1, don't change the next hop. So when 1 sends it to everybody else, if I don't change the next hop, it'll point to 192.168.1.2 for routes for 2. Similarly, for 3, it'll be 3, 4, it'll be 4, 5, it'll be 5. Now my routing table will have a next hop pointing to either 2, 3, 4, or 5 respectively for the different type of routes. So when I go to do my resolution, I'm going to do the resolution for the appropriate next hop. So my data traffic will flow directly from spoke to spoke. All right? How? Let me just show you. On the hub, if you want this to happen where the data traffic needs to go directly from spoke to spoke and not come through that hub and spoke type environment, go under the tunnel, specify no IP next hop self for EIGRP 100. So basically saying any updates that are coming in through the tunnel and going back out, don't change the next hop. Again, because of the change, it will reset your neighbor relationships. If I go to router 2 now, do you remember this? Everything was pointing to 1 because of this config change. Now I will have 1, 3, 5, 1, 3, 4, 5, 1, 3, 4, 5 from the appropriate destination, the actual destination. So now, if I want to do a trace route from router 2 to, let's say, 10.3.3.3, the first packet will go up to whom? To the next hop server to resolve. How do I get to 10.3.3.3? Or not 10.3.3.3? How do I go to get to what? 192.168.1.3. Says 192.168.1.3 is reachable via 30.3. Says thank you, the next packet direct. Take a look. So the first one, it went there, but then it resolved it, went direct. So now my traffic is going directly between what? 2 to 3. Or for that matter, if I want to go to 4, the first packet, yes, will go through the hub because I need to resolve. Once a resolution has taken place, the next packet goes direct. And if you check your NHRP mappings now, you will see dynamic mappings created for 3 as well as for 4. And the reason for that is because now my routing table shows what? The next hop as the actual next hop for that network, not the hub. And this is Dmvpn Phase 2. So how do I do this though? Which one? The 2 hours? Absolutely, under the tunnel. I'll show you that as well if you want. But before this, Dmvpn Phase 1, just to complete your notes, how did I accomplish that? On router 1, the routing hub. Well, this one is the default, so I don't need to do anything about this. Sorry. Dmvpn Phase 2. Yeah, disable split horizon, which is not even Phase 1. It's just EIGRP part. in this phase, no, it's the same. Oh, advertised distance. Yes, the metrics do change. Metrics should change. No, not take that back. No, it doesn't change. Why? Because the metrics were, even if it did change the next hop, the metrics were the same. Over here, what should remain the same. We'll check that. In this phase, your how should I say, your traffic, it shouldn't change now. In this phase, let me see how I want to phrase this. You tweak the routing protocol to not change the next hop of the routes that are getting propagated. This allows the spokes to resolve the next hop to the actual router public address. But what did I do over here? The key thing I want you guys to take a look at is you tweak the routing protocol to change the next hop. All right? In this phase, traffic in this phase, the traffic goes directly from spoke to spoke. How did I accomplish that? Interface tunnel 1, no IP, next hop, self EIGRP 100. Correct. The first packet goes through there. There's some questions I wanted to take a look at. From a layer 3 perspective, the tunnel is connected between the spokes, right? But from a layer 2 perspective, does the traffic still go through the hub? No, because the packet, the way it works is like this. Let me just show you the packet. But before that, I want you guys to see the before and after in terms of the, for example, for these guys is 280.880, 282.880 because it's the same interface. All right, so the metrics won't change. The other thing, the question that was asked was about the layer 2 aspect of it. The way it works over here is after the initial packet that went through, let's say router 2 wants to talk to router 3. There's a router 6 in the middle, which is the internet, and there's router 1. Taking our example, LA, Boston, and New York, they're connected to each other. This is the internet. Now what happens is, if I look at my routing table over here for 10.3.3.0, it says the next hop is 1.3. All right. So what it does, it creates a packet. The initial packet was 10.2 to 10.3. Now it needs to create the outside header. Source is 20.2. First thing it'll do is it'll send, try to do the resolution for how do I reach 192.168.1.3. That packet, that initial packet goes to R1, gets it back. So R2 to 4, 6, 6 to 1. Once I get the packet, I get the resolution. I will know in order to reach 192.168.1.3, the next hop is 30.3. Get it? So now I'm going to put that into my outer header. So the packet that gets sent from where? From router 2 to router 6 looks like this. So it doesn't physically layer 2 wise go to LA. It goes to the internet. Internet says, oh, how do I reach 30.3? Sends it over here. Does that make sense, guys? Somebody asked me the question. Who was it? Just check. Antonio. You get my point. So it's actually not even hitting router 1 after the initial one. The initial one is the resolution. All right. The other question was, can I change it, tune the timer? NHRP, this is the expiry timer. I remember the... hold on. This is the one, which is set to 7,200 seconds by default. You can change it. 2 hours is the default. Got it? Everybody okay with that? So that is phase 1, phase 2 with EIGRP. Absolutely. Show Dmvpn. What's the one? Detail, I think. So it shows you the mappings as well. Clear? Everybody okay with that? So this is phase 2. Any questions so far? Now, phase 3 is very similar to phase 2 in the sense that phase 3 also has you do the spoke-to-spoke communication. But the difference in phase 3 is this part over here. With phase 2, I'm working with my routing protocol to make it run as spoke-to-spoke. My routing update changes, which in turn changes the CEF. Phase 3 does not rely on the routing protocol to do that. Phase 3 uses NHRP to override the CEF table of the spokes to tell it, hey, listen, you know what? 10.2 or 10.3, it creates the actual mapping for the internal networks. Rather than just changing the next hop, I will actually create a mapping for the internal networks. Let me show you that so you guys see the difference before and after. If I take a look at my NHRP mapping over here, what addresses do I have mapped over here? The tunnel IPs, correct? If I want to reach 1, 3, or 4, the next hops are whatever they are, right? But they're tunnel IPs. So if I'm sitting on R2 and I want to go to R4, for example, this is my destination. I check my routing table. In my routing table, what do I see? In order to get to 10.4, the next hop is 192.168.1.4. So it says, oh, 192.168.1.4 is 40.4. So what am I using to do the spoke-to-spoke mapping? This guy. Agreed? So the mapping is for the tunnel IP over here. What I'm going to do in phase 3 is I'm going to not do it based on the routing table, but instead I'm going to do it based on NHRP rewriting your CEF. Rewriting it so that I actually have a mapping in my NHRP table over here for saying if I want to reach 10.440 in NHRP, go via 192.1.40.4, which is the public address, this address of, what do you call it, for this internal address that was learned through the routing. To do that, first thing that I'm going to do is I'm going to go back to phase 1 so that as if all my routes are learned via what? I'll say IP next hop self, EIGRP 100, reset it. So now if I take a look at my routing table, let's do it for EIGRP. Everything is going through what? The hub. So if I do a trace right now to 10.333 from 10.222, Because of the next hop resolution, I'm always going to go through what? Through the hub. So it's back to phase one. Agreed? I'm going to use NHRP to override this. I'm going to tell NHRP, make it a little bit more intelligent, tell it that, hey, listen, this guy is sending me a packet which is coming to me through the tunnel, and I'm sending the packet back on the tunnel to this guy. That means these two guys are directly connected to each other. The destination of the packet was 10.4.4.4. Let me go ahead and give these guys a mapping to tell them, hey, listen, if 10.4 is to be reached, the next hop is 40.4, and it's going to do it dynamically. And I'm going to tell him, if you want to reach 10.3, go directly to 30.3. Why? Because I detect that the packet is coming in off the same interface, going back on the same interface. The packet was from 10.3 to 10.4. Let me tell these guys their next hop addresses. This is done by using NHRP redirect. If I turn on NHRP redirection on router 1, the hub, it is going to send that redirect message to whom? The two spokes, telling them, hey, listen, why don't you guys talk to each other directly? Leave me alone. You get my point? Through NHRP, but it doesn't work just like that. When I send him the redirection message, R3 and R4 need to be equipped to take on that redirection. You need to enable something on those spokes to take on or accept that redirection. So on the hub, I will do the redirection by just putting a single command in. By the way, you guys are okay with this. You understand that I'm going direct from what? I'm not going direct right now. I'm doing phase one right now. All my routing entries are pointing towards what? Towards the hub. So technically, what phase am I in right now? Phase one, absolutely. Okay, so how do I turn it into phase three? On the hub, tell it to do the redirection. When I turn this command on, I'm basically telling router 1, detect these packets that are coming in, data packets that are coming in and going back out of your interface, try to have them talk to each other directly. I'll explain that as well. I'll go through that, the advantage of doing phase 3 over phase 2. So I do that over here. Now in router 2, if I take a look at it over here and I do the trace route, although I have turned on the redirection over there, if I try to go over to 10.3, it is still going through what? No, there's something else I need to do on the spokes though. So if you take a look at it, it's still going through what? The hub. So although I'm getting the redirection from the hub, I'm ignoring it. Correct, Craig? You need to turn on the acceptance of that redirection message. And how do I do that? On the spoke. Under the tunnel interface, I'll say, I will take the shortcut that you're giving me. So the IP NHRP shortcut command actually accepts that redirection. Says, okay, yeah, okay, I'm going to go and take your redirection and go directly. Up to this point, I was just avoiding it or ignoring it. So on the spokes, I do IP NHRP shortcut. All right, let's go back to router 2 now. Now that I have the shortcut in place, I'll do a trace route. The first packet will go through. It will send me a redirection message again. Says, okay, thank you. I will go there. Does it change my routing update? No, it doesn't. If you check your routing update, and that is the difference over here. My routing update is still pointing to what? The hub. But what it has done a Ceph update. And hence this indication over here that there's a next hop override. Where? Not over here, but in your Ceph. You check your Ceph to get to 10.3. It's pointed to 10.3. Somebody asked me what is the actual difference between the two. That's one difference, that it actually updates the Ceph. Although it doesn't do anything to your routing update. So if you look at your routing update, it just still shows you 192.168.1.1. It does give you an indication that something has happened. To be honest with you, it actually does. No, the other one also updates the Ceph, but not directly. Phase 2 will also update the Ceph, but it updates the routing table, which in turn updates the Ceph. Whereas this one, NHRP, updates the Ceph. Now, in reality, the actual route is being sent through NHRP into the routing table. You don't see that. You actually have a route that is being sent through NHRP into your routing table, telling it, hey, listen, if you want to get to 10.3.3.0, the next hop is 192.168.1.3. It is done through H. You see this H over here for NHRP? It's done through that. But the problem with NHRP in terms of the routing table is its administrative distance is 250. So in the routing table, you won't see that H. But it does also have this other mechanism where it actually changes the next hop in Ceph, which is what it's used. What if using a dual hub? It would get the route from both the hubs. But either way, I'm going to use the Ceph over there. I'll show you that 250 as well. Give me a second. That's the other advantage that I have over here. Right now, what is happening is I have 80 or 250, correct. Right now, what's happening over here is that I am receiving all the spoke-to-spoke routes, right? If in phase 2, I wanted to do summarization on the hub, and I do summarize on the hub. Let's say on the hub, I go in and I say, in phase 2, interface tunnel 1, IP summary address, EIGRP 100, 10.0.0.0, 255.0.0.0. Can I do that? Sure. Now, once I do that, I'm not going to send any of those 10 addresses from the spoke to spoke. And now in phase 2, I only have one network, the 10 network. What's the next hop for the 10 network? Because I'm not sending 10.2, 10.3, 10.4. Because of the summary, everything will point towards the hub. So in phase 2, summarization is not possible for these spoke routes. But over here, it is. If I summarize over here, and I want you guys to see this, and I check my EIGRP table, I only have one route, which is 10.0. But if I want to go there, I'll still use the direct path. So I've cut down on my routing table, all right? And I'm doing spoke-to-spoke communication because of the NHRP redirect. Somebody asked me the difference, the functional difference between phase 2, phase 3. This is the biggest advantage that you have in phase 3. Which part, Antonio? Not phase 1, phase 2. Phase 1 is hub and spoke. The difference is between phase 2 and phase 3. Although my routing update is what? Routing table over here shows what? In phase 1, there is no summary because everything is, you can summarize it, but now all the traffic goes through the hub. It's hub and spoke. Yes, you can summarize in phase one, but again, the traffic is now going through the hub. What I want to do is I want to be able to summarize, but at the same time, I want traffic to go from spoke to spoke. Correct. They need to have a full mesh topology type of thing. Yeah. Now, do you guys remember what I told you about that H, the 250? I just showed you show IP route EIGRP. Take a look. If you do a normal route, you should see that H now. So it actually does update your routing table. So if I ping the other guys, so trace route to 10 dot, what do I have? 444. First one does a redirect. The second one goes direct. Now check your routing table. You will see a bunch of more H's over here. You guys seen that before, the H? You won't see it unless you summarize it. Because its administrator distance is 250, so you never see it. All right, that is phase 3 for you guys. Everybody okay with that? Yep. NHRP. So let me write this down for you guys. So the third phase, Dmvpn phase 3. I'll just copy paste this. A lot of the stuff is similar. In this phase, you tweak the NHRP to do a redirection for the spoke networks. NHRP creates a resolution for the spoke routes in addition to the tunnel IP. Absolutely correct. Absolutely correct. And that's what you guys are seeing over here. See over here, I am summarizing, so I'm not getting all the routes from all my spokes, but at the same time, I'm still going spoke to spoke. Very true. Very true. Because it can be misleading, because when you take a look at the routing table, you will see that routing table is what? Pointing to the hub, but the actual traffic is going direct. The Ceph would be updated, but the routing table would not be. What's that, Noah? GDIL? I didn't get that. Good, I'm glad you know it now. Okay. All right, so this is EIGRP. You guys are okay with this? Let me make sure I finish this. In this phase, traffic goes directly from spoke to spoke. How do I do it? On the next hop server, which is router 1 in my case, what do I do? And the NHCs, which are clients, Everybody okay with this? You guys ready for OSPF? Bring it on. OSPF is never the same. So first thing I'm going to do is I'm going to get rid of EIGRP on all the different devices. I'll do it through my command window. Yeah, you need to do that. That's how you learn. That's the way I learn it, at least. So in my command window, I'll say no router EIGRP 100, get rid of it. From all my devices. So EIGRP is gone. It is tomorrow. It depends on which time zone you're at. So now EIGRP is gone. Let's run OSPF. Now OSPF by default will not run on an MGRE tunnel. Why? So this is that. Now OSPF over Dmvpn does not run by default. Why not? OSPF has this issue about network types. OSPF treats every network as a certain type of network. Yes, somebody's mic is on. The network type that OSPF treats the tunnel interface as is a point-to-point interface. So if I run OSPF on the tunnel interface, how many devices do I have on that tunnel interface over here? I have 5 or 4 neighbors, correct? No probs. By default, OSPF will treat this tunnel interface as point-to-point. That means I can only have one neighbor. You get my point? So that's going to be an issue. The first one comes up, it says, okay, up. Another one comes up, it brings the other neighbor up, brings the other one up. So that's going to be an issue with OSPF. You need to change the network type on every interface. The interface that you need to support over here, there are 2 types. The default one is point-to-point. It does not work. OSPF network point-to-point does not work. What you need to do is you have 2 choices. You can either run broadcast or you can run point-to-multipoint for this to work. Okay? And the network type is the one that determines whether you want to do phase 1 or you want to do phase 2. What was phase 1? All the traffic through the hub. And what caused phase 1? The next hop changing, correct? Agreed? So let's do phase 2 first. Where I want traffic to go directly from what? Spoke to spoke. How did I accomplish phase 2? By tweaking the routing protocol so that it does not change the next hop. Do you guys remember that? So over here for OSPF, what I'm going to show you, I'm going to write it based on phase 1, phase 2. But the way I'm going to do it first is I'm going to do phase 2 first, phase 1, and then phase 3. Phase 2 was spoke to spoke, changing the or tweaking the routing protocol to do that. Broadcast is a network type in OSPF, the Ethernet one. broadcast multi-access, in which when router 2 sends an update to router 1, it does not have split horizon issues, but when router 2 sends the update to router 1 knows it's on the same network. It does not change the next hop in broadcast networks. It keeps it the same on the same interface. Hub needs to be the DR. And how do I make sure that hub is the DR? The way I make sure that the hub is the DR is by going in onto my other devices and setting the priority to 0. 0 is a special priority, which specifies I'm not going to participate in the election. Everybody okay with that? So I want to make sure this is the DR. When they send me the updates, I'm going to send the updates back to everybody. But in a broadcast network, as an attribute of a broadcast network, OSPF does not change the next hop. So basically, R2 will get an update from R3 saying, or R1 saying that if you want to reach 10.3, go to R3. Let's take a look at that. So if I want to do OSPF Phase 2, the way I would do that is on all the interfaces. First of all, let's run OSPF. Router OSPF 1. Network 192.168.1.0.0.0.0.255 area 0. Network 10.0.0.0.0.255.255.255 area 0. Now this is going to be the problem over here. Do you see that? Adjusting, starting, coming back, starting, coming back. Why is this? Because of that point-to-point setup. So what I want to do is on the hub, if it lets me type interface tunnel 1, IP OSPF network, we'll say broadcast. All right. R2 interface tunnel 1, IP OSPF priority 0, IP OSPF network broadcast. Router 3, the same thing. For the same thing. Is this a standard broadcast? Standard broadcast. Now, if I go to router 1, I should have all my OSPF neighbors set up. And this should remain there with a priority of 0. But if I go to router 2, the next hops are pointing to the actual what? Spokes. So 10.1 from 10.1, 10.3 from 10.3, 4 from 4, 5 from 5. Everybody okay with that? So that's the characteristic of an OSPF network broadcast that will automatically make it Phase 2. So the way you accomplish Phase 2 in OSPF is by tweaking the routing protocol to run as a broadcast network. Everybody okay with that? You guys understand that? How do you accomplish Phase 2 in OSPF? It's just working with the network type. Make sure the hub is the DR. I'll put that in your notes as well. Make sure the network type is broadcast. The rest is all taken care of. What about if I want to do Phase 1? What was Phase 1? Hub and spoke, where the next hop does change, right? That's the characteristic of the OSPF network type, point to multi-point. So if you change the network type to point to multi-point, it will automatically do the changing of the next hop, causing Phase 1. UB becomes, say that again, hub. Okay, hub becomes DR by setting priority on all the other routers to 0. Yes, because the spoke router setting to 0, they won't participate in the DR-BDR election. So even if I have 1 on the hub, it automatically becomes the DR. If you have a dual hub type of scenario, you would set the priority to whichever one you want the DR to be a little higher. That is correct. That is correct, Vinod. So this is phase 2. How do I do phase 1? On all the routers, on the tunnel interfaces, tunnel 1, I would say IP, OSPF, network point to multi-point. This is the network type for phase 1. Why? Because this one will change the next hop. Just like EIGRP does by default, the next hop behavior is controlled by your network type. So now that I've changed it, let me see, make sure my neighbors are up. Yep, they're all up with the dash, no DR, BDR election process over here. Why? I'm a point to multi-point network type. But if I check my routing table now, it's all going to point towards what? What is that? That's your hub and spoke. So if I do a trace to 10.3.3.3, going through the hub, and it's going to continue going through the hub because that's exactly what this does. So how do I do phase 1 and phase 2 in OSPF when you're running OSPF as your routing protocol over the Dmvpn network? You accomplish that by changing the network type. Everybody okay with that? That's it. That's how you do it. It's as simple as that. How about phase 3? Phase 3 is exactly the same. NHRP redirect on the hub, NHRP shortcut on the spokes. Because regardless of what I'm doing where, under my routing protocol, it always takes it from, what do you call it, from NHRP because it overrides it. So if I wanted to do that, I would say IP NHRP redirect, IP NHRP shortcut on the hub and spokes. Make sense, guys? So let me write this down for you guys over here. Does not run by default. What's the reason? Reason being that OSPF treats the tunnel interface as a point-to-point interface which only allows a single neighbor. Phase 1, change the network type to point to multi-point. In this network type, on all devices, by the way, it needs to match. The hub changes the next hop to itself, causing the traffic to go through the hub. Phase 2, so all I had to do over here was what? Tunnel 1, IP OSPF network, point to multi-point on all devices. All right, phase 2. I'll just copy it. Change the network type to in the network type in this network type, the hub does not change the next hop. The next hop on the spokes points directly to the other spokes, causing direct traffic communication between the spokes. I'll do it differently over here on the hub. Done. Phase 3 is the same. Phase 3 because it really doesn't matter what the routing protocol does, I'm going to override it anyways. So what was the question that you guys had? Correct, because I'm going to override it anyways. Absolutely correct. That's OSPF for phase 1, phase 2, phase 3. Good. Let me just save this. Dmvpn. Yeah, no problem. 1 second. Notes. Let me save it in the proper place. Too many places. All right. IP NHRP map multicast. When a multicast packet comes in, so when a routing update comes in, so I'm sitting on, let's say, router 2, and I'm running EIGRP as my routing protocol or OSPF, it doesn't matter, whatever routing protocol I'm running, the packet comes in because I've enabled EIGRP or OSPF on my tunnel interface. It's going to try to send an update, hello packet on the tunnel interface using 224.0.0x as a destination. Now, what I need to do is I need to create the outer header over here so I can send it to the appropriate destination. My normal maps are for unicast packets, but this is a multicast packet. So my source is my public address of the tunnel. I need to create a mapping to specify if a multicast address is in the inner header, where do I send it to? And that's exactly what the NHRP map multicast does. It basically says if a multicast packet comes in, which is 224.0.0x, whatever it is, send it to my routing hub. If I don't do that, it will not. NHS is the normal NHS stuff that you have is only for unicast packets. It's not for multicast. So I need to create a special entry for multicast specifying if a multicast packet comes in, which is my EIGRP, OSPF, RIP, all these updates, where do I send it to? Make sense, Craig? To make my multicast based routing protocols run, I need to do that. So on the dynamic, it specifies, see, if I'm on the hub, that's a good question. If I'm on the hub now, on the spokes, it's simple because I'm only sending my update to the routing hub. But he needs to send that update, that 224. He's also going to send a multicast update to whom? I want to be able to send it to everybody. But I don't know, I don't have any manual maps, or I don't even know the addresses of these other guys statically, so I won't be able to configure map multicast and specify each of those public addresses. So on the hub, I say map multicast dynamic. The reason for that is it says, listen, go into your NHRP table, find out all the mappings that have been done dynamically and send an update to everyone, because these are all your clients. So if you go to the hub, you will see a whole bunch of dynamic mappings that were done on the 192.168.1 network. It says, oh, this is dynamically created, so I'm going to send an update to this guy. I'm going to send a multicast update as a unicast to 20.3, 20.2, 30.3, 40.4, 50.5. So I'm actually going to send 5 unicast packets, but the inner packet is a multicast packet. So I can communicate to any device that comes up. So if I have 100 or 200 devices that are registered, I'm going to send a multicast hello packet to every one of them that has registered to me dynamically. Otherwise, I would need to do a multitude of map multicasts on the hub. That is correct. On the spokes, you would always point to the hub as your unicast multicast. Now, the other thing that you also need to understand, Craig, we haven't gone into that. You have multi-tiered Dmvpn type of setups, where you might have, at the top, you might have a Dmvpn setup where these are 2 spokes, and this then acts as a hub to another 2 spokes. So you can also do that. So you have a Dmvpn tunnel over here and a Dmvpn tunnel over here. Multi-tiered Dmvpn setups as well. You can do that as well. But yes, it's a different tunnel, but the concept, you understand that. You have the ability to scale it even further. All right. Sure, why not? Well, I'll sit with Catherine and set it up. I'm a little busy the next 2 weeks, but after that, in August, we should be able to do that. Can you tell all traffic through the DMVP? You can run ISIS if you want. Dual hubs in HSRP manner. Not sure exactly what you're looking for with the dual hub with HSRP. HSRP would be on the inside, right? Are you wanting to run it on the HSRP is towards the client-facing type of thing? FlexVPN is phase 4. No, it gives you, see, right now, just to give you an idea of what FlexVPN is, right now, let's say you want to do a spoke-to-spoke communication. You set up a LAN-to-LAN VPN tunnel. The configuration is different. You want to do a multi-point VPN like we did over here that the spoke-to-spoke communication is allowed. That is a completely different type of VPN setup. If you want to do a client-server type of setup today, you would do EasyVPN. So if you look at the configuration models of the 3 VPNs, they're completely different. FlexVPN allows you the ability to do all these configurations in one place. So that's what it is. What was this? Okay, a little bit about myself. Oh, I do. Thank you, guys. In terms of training, what type of training do? I do route switch, I do security, I do service provider, I do data center, I do CCDE, I do trainings on all the different subjects. I do have 6 CCIEs and I actually use them. I teach on 4 of them, and I also the CCDE as well. If you want to reach me, my email address is Khawar at khawarb.com. You can also, I also have a YouTube channel that Catherine referred to. This is a channel, and you can take a look at a lot of different videos. Some of the, if you guys are going for route switch, these are some nice videos about things like running MPLS VPN with Dmvpn, using the internal VRF, also using FBRF, a whole bunch of nice videos in terms of routing and switching. Where am I based out of? I'm based out of out of a suitcase. I travel a lot, so I do. I'm based out of Dubai. Go to London. I do classes all around the world. I do classes in LA as well for all the different subjects. So if you need more information, send me an email. I'm actually starting a route switch class tonight. Thank you. Send me an email. I'll send you the information about that. Generally, they are, yes. But that's why I do the videos, just on the technology perspective of it, but the classes generally are based on that. Send me an email. I'll send it to you. I'll also post a schedule. My next class for CCIE security is on the weekends. It's in August 12th or 13th, the weekend of August 12th or 13th. Currently, I'm going to start the route switch tonight, which is morning for you guys. And I'm currently doing the data center class. I do have an annual package where you get access to all my classes for a year for one cost, which is a great value. I think Catherine has signed up for that, and she can vouch for that. In that, you get access to all my classes, not necessarily from learning it from the CCIE perspective, from the technology perspective. It's a great course. It basically is all your CCIEs in one shot, in 1 year. Just send me an email on my email address. I'll give you all the information about that. Thanks, guys. Hope you guys enjoyed it. Have a nice weekend, everybody. Thank you, guys. Take care.